HAProxy is the load balancing specialist, a high-performance reverse proxy built to distribute traffic across pools of backend servers with surgical precision. Every HAProxy configuration is built from two sections. The frontend is the listener, the IP address and port that accepts incoming client connections. The backend is the pool of upstream servers that actually do the work. Here is the canonical flow. A client connects, HAProxy's frontend on port 80 receives the request, hands it to a backend named web, and that backend forwards it to one of three servers. In mode TCP, HAProxy operates at layer 4. It just shuffles raw bytes between client and server without ever parsing HTTP. This makes it blindingly fast and completely blind to headers, paths, and cookies. It is the right choice for raw TCP, SSL pass-through, databases, and any non-HTTP protocol. In mode HTTP, HAProxy climbs to layer 7 and actually parses the HTTP request. It can inspect the host header, the URL path, cookies, and any header, which unlocks virtual hosting, path-based routing, and sticky sessions. HAProxy offers multiple balancing algorithms, round-robin cycles through servers in order 1, 2, 3, 1, 2, 3, and is simple and fair when all servers are equal. LeastCon picks the server with the fewest active connections, which is the better choice when requests take varying amounts of time to complete. For HTTPS, you have two strategies. SSL termination places the certificate on HAProxy with a bind line like bind asterisk, 443 SSL CRT etc SSL cert.pem. HAProxy decrypts the traffic in backend C-plane HTTP, which simplifies backends and offloads CPU. The alternative is SSL pass-through in mode TCP, which keeps encryption end-to-end, but requires every backend to handle TLS itself. Terminate at HAProxy when you need layer 7 routing on HTTPS. Pass-through when you require end-to-end encryption. Finally, HAProxy watches your backends with health checks. The option HTTP/CHK, directive and the check flag on each server line probe the backend, and HAProxy displays a green status for healthy nodes and red for failed ones. Failed servers are removed from rotation automatically. HAProxy is a battle-tested load balancer, and the fastest way to understand it is to run a tiny config that round-robins two HTTP servers. We will start two Python web servers on ports 8081 and 8082, then put HAProxy in front of them on port 8080 to distribute traffic evenly. Before anything else, we confirm HAProxy is installed and on the path. The which command locates the binary, so we know exactly which executable we are about to run. Next, HAProxy v prints the version banner along with the build options, giving us the exact release and feature set in play. This is useful for matching config syntax to the running daemon. The whole setup hinges on a minimal haproxy.cfg. We cat the file to show the listener, the two backends, and the round-robin balance directive that makes alternation deterministic. We need real backends to balance against, so we launch two Python HTTP servers in the background, one per port, redirecting their logs so they stay out of our way. The ampersand returns control to the shell immediately. With the backends up, we start HAProxy in the foreground using the debug flag, which keeps it attached to the terminal and surfaces verbose startup logs. The config is reloaded in process, the frontend binds 8080, and the two backends transition to up. To prove the round-robin is alive, we hit the frontend with curl, and inspect the HTTP status code the backend returns. A 200 means the request was accepted, routed, and answered by one of the two servers. Finally, we confirm the listener is actually live with SS, filtering for port 8080. Seeing HAProxy bound on that port in listen state is the proof that traffic will be accepted and dispatched to the two backends in turn. Think of HAProxy as a shapeshifter. Flip it into mode TCP and it becomes a pure layer 4 forwarder. The exact same role AWS Network Load Balancer plays in the cloud. Zero HTTP awareness, ultra-low latency, TLS pass-through only, and absolutely no header or path routing. Raw packets in, raw packets out. Now flip the switch to mode HTTP and HAProxy transforms again. This time into a layer 7 inspector that reads hosts, paths, and headers, terminates TLS, and routes intelligently across backend pools. That is the same job AWS Application Load Balancer was built to do. The feature surface lines up almost one-to-one with HAProxy frontends and backends. Stack them side by side and the trade-offs are obvious. Self-hosted HAProxy runs at layer 4 or 7, speaks HTTP when you want it to, terminates SSL on your terms, and ships with surgical health checks. But you pay an operational burden and run it on your own metal. NLB is cheap to operate, pure layer 4, no HTTP awareness, TLS pass-through only, basic health checks, billed by traffic an hour. YLB sits at layer 7, full HTTP awareness, native SSL termination. Target group health checks, build by usage, and AWS handles the ops for you. Then there is Nginx. Nginx is a web server first and a load balancer second. It ships upstream blocks with IP_hash and least_con, plus proxy_pass for layer 7 routing, which makes it perfectly capable for small and medium sites. But HAProxy is purpose-built for load balancing. Richer algorithms like round-robin, least_con, URI, HDR, and RDP cookie, first-class health checks, a detailed live stats page, and a decade plus of battle testing under extreme concurrency. The rule of thumb is simple. Pick Nginx when you also need a web server doing real work on the box. Pick HAProxy when load balancing is the primary job and you want maximum flexibility, granular routing, and deep observability into every connection. So when you are choosing your layer, the answer is dictated by the traffic. Reach for layer 4, AWS NLB or HAProxy in mode TCP. When you need raw performance and your traffic is non-HTTP, reach for layer 7, AWS ALB, HAProxy in mode HTTP, or Nginx, the moment you need path, host, or cookie-based routing. Match the layer to the problem, and the rest falls into place.